Hi friends, in this video we are going to discuss about types of rotors. In induction machine we have two types of rotors. In that first one, slip ring induction rotor. Let's discuss about slip ring induction rotor. Slip ring induction machine or slip ring induction rotor. The slip ring induction machine is also known as wound rotor. This is also known as wound rotor. Wound rotor induction machine. Wound rotor induction machine. We are called as wound rotor induction machine. Right, let's see about this. For example, the stator is the delta connected winding. This is my stator, which is excited by the supply voltage, three-phase AC supply, and due to mutual induction again here, and here this is my rotor, this is my rotor. This rotor should be star connected. In our slip ring induction machine, the rotor should be star connected. Because why? Because here in slip ring induction machine we have a slip rings. In slip ring induction machine we have a slip rings. Also. Here we have a slip rings. For example, here I have slip rings like this. Here I have a slip rings. Three-phase slip ring induction motor having three slip rings. Three-phase slip ring induction motor having three slip rings. These are my three slip rings of induction machine. Why the rotor should be star connected? Because in order to connect to this rotor terminals connected to the slip rings. In order to connect the slip rings, we should take the rotor as a star connected. For example, here I am taking the slip rings and I am connected like this. This is simply our slip ring induction machine. In slip ring induction machine, the stator is delta or star any, but the rotor should be star connected in order to connect the rotor terminals to the slip rings. Right, slip rings. These are the slip rings. Now, the points about this one. First of all, in slip ring induction machine, the rotor is wounded with distributed winding. The rotor is wounded with distributed winding. That's why it is called as wound rotor. This is wounded with distributed winding, which is short pitched distributed winding generally we are using. And next one, generally in this rotor, the rotor terminals are not short circuited. Rotor terminals not short circuited. These rotor terminals connected to the slip rings. That's why this is not short circuited. These rotor terminals connected to the slip rings only. And next one, generally in induction machine as well as in synchronous machine. In induction machine as well as in synchronous machine, the poles of the rotor must and should be equals to poles of the stator. The poles of the rotor must and should be equals to poles of the stator in any AC machine. Either in induction machine or synchronous machine, the poles must and should be same. But in our induction machine, the phases of the rotor may or may not be equals to phases of the stator. The phases of the rotor may or may not be equals to phases of the stator. If the phases are equal or not equal, no problem. But the poles of the rotor must and should be equals to poles of the stator in our induction machine. This is very important one. This is very important one. If poles are not equal, there is no induction machine operation. If both the poles are not equal, there is no induction machine operation. Right? What are the points? Here we are using distributed winding. And next one, the rotor terminals are not short circuited. Rotor terminals connected to the slip rings. Rotor terminals connected to the slip rings. And next one, the rotor poles must and should be equal to stator poles. But the phases may or may not be equal. The rotor phases may or may not be equals to stator phases. May or may not be equals to stator phases. Right. I told you that here the poles of the rotor must and should be equals to poles of the stator. Generally the poles are formed due to winding procedure. The poles are formed due to winding procedure. I will give you, for example, see here. For example, I am taking 4 coils. For example, those 4 coils are connected like this. For example, I am taking 4 coils. For example, I am taking 4 coils. For example, I am taking 4 coils like this. For example, I am taking 4 coils like this. For example, this is my current direction. For example, this is my current direction. Let's see, the current direction in this coil is like this. The current direction in this coil is like this. And the current direction in this coil is like this. And the current direction in this coil is like this. When current direction in both the coils are opposite, then poles should be formed at that place. See here, current directions are like this. That's why here, north pole will form, north pole. For example, the current directions are like this, opposite to each other like this. South pole will form here. For example, again the same direction, north pole here. Like that, we have a poles due to winding procedure. Due to winding procedure, we can get the poles. We can get the poles like this. We can get the poles. Right, let's see here. The poles of the rotor should be equal to poles of the rotor. Poles of the stator and rotor should be equal. Nothing but by winding procedure, we can get the same poles. And here, the very important point is that generally in induction machine, we can control the speed by changing poles. By changing poles, we can control the speed of induction machine. That speed control method is very difficult for slip ring induction machine. In slip ring induction machine, the pole changing method is very difficult. Why it is difficult? If I want to change my speed by pole changing method, I have to rewound for rotor and I have to rewound for stator, for both. Then only we can control the speed. Because if you change the poles in stator, there is no operation because the poles of the stator must and should be equal to poles of the rotor. That's why we have to change poles in stator as well as rotor. Nothing but we have to rewound for stator and rotor. We have to rewound for both stator as well as rotor. That's why the pole changing method, speed control by pole changing method is somewhat difficult for slip ring induction machine, which is not preferable here actually. Which is not preferable here. Okay, so whatever poles are formed due to winding procedure, you have an idea how the poles are formed. Right? Next one. Generally, in induction machine, the starting torque is directly proportional to rotor resistance. I will give you the torque equation, then you can conclude that. Okay, just now remember the starting torque directly proportional to rotor resistance, and generally we know power factor cos pi is equals to R by Z. We know that value, cos pi R by Z, power factor. And also starting current is nothing but V by Z. starting current is equals to V by Z. Now tell me, generally in our slip ring induction machine, we are using a winding. Generally it have a low resistance actually, but the advantage of the slip ring induction machine is that we can increase the rotor resistance. How we can increase? By adding extra resistance with the help of these slip rings. By adding extra resistance with the help of slip rings. How, sir? How we can add the extra resistance? Let's see here how we can add extra resistance. Let's see here how we can add extra resistance. Let's see here. If I'm taking some extra resistance RE, I'm taking some extra resistance RE here, some extra resistance RE. Now we can connect this extra resistance to the slip rings. We can connect this extra resistance to the slip rings. If we connect here, this is nothing but in series to the rotor. In series to the rotor. That's why I told you the rotor of the slip ring induction machine should be star connected. The rotor of the slip ring induction machine should be star connected in order to connect extra resistance through the slip rings. In order to connect extra resistance through the slip rings in series to the rotor. Then only we can increase the total resistance value. If total resistance increases, we can increase the starting torque. If total resistance increases, we can increase the power factor. If total resistance increases, tell me, we can control the starting current. So, let's see here. By adding extra resistance, which is in series to the rotor, we can improve starting torque, we can improve power factor, and we can control starting current of the machine. These are the most important points in our slip ring induction machine. So, in slip ring induction machine, what are the points? In slip ring induction machine, generally we are using distributed winding. That's why it is called as wounded rotor. Generally, in slip ring induction machine, the rotor terminals are not short circuited. Rotor terminals are connected to the slip rings connected to the extra resistance RE, which is in series to the rotor circuit. We are adding extra resistance through the slip rings in series to the rotor circuit, because starting torque directly proportional to rotor resistance, power factor directly proportional to rotor resistance. Yes or no? Yes, sir. So by adding extra resistance, we can improve starting torque, we can improve power factor, and also we can control the starting current. Right? Next one. In this machine, poles are formed due to winding procedure actually. Even in stator as well as rotor, we have a distributed winding. That's why generally the poles are formed due to winding procedure. The speed control by pole changing method is very difficult. That's why not preferable. Because if we change the poles, we have to rewound for stator as well as rotor. Because we have one condition. The poles of the rotor must and should be equal to poles of the stator. That's why the speed control by pole changing method is not preferable. And next one, the phases of the rotor may or may not be equals to phases of the stator. And next one, generally this is about the slip ring induction machine. I already told you here we can increase the starting torque. Now they are asking question. What are the applications of slip ring induction motor? What are the applications of slip ring induction motor? The applications of slip ring induction motor is high starting torque applications. High starting torque applications as well as variable speed applications also. They are called that variable speed applications. Sir, you told you that we cannot control the speed by pole changing method because it is very difficulty. That's why we are not preferring that method. I said you already. But in application, I am telling you that high starting torque and variable speed, where we can control the speed. In those cases we can use where we can controllable, the speed is controllable. In that cases, we are using the slip ring induction machine. Sir, this is okay, high starting torque applications, but you telling that we can control the speed. How we can control the speed? By changing the extra resistance. By changing the extra resistance, we can control the torque as well as speed. This is very important. So, in slip ring induction machine, pole changing method is not preferable, but the speed changing method of resistance variable. By changing the rotor resistance, we can control the speed. By changing the rotor resistance, we can control the speed in slip ring induction machine. That's why the resistance control speed control method, the resistance change speed control method is well preferable here. In slip ring induction machine, how you can control the speed? One is pole changing method and second one is rotor resistance control method. Which is preferable? Rotor resistance control method is well preferable. The pole changing method is not preferable because here we can control the rotor resistance by adding extra resistance. We can increase the rotor resistance by adding extra resistance through the slip rings in series to the rotor circuit. That's why we can control the speed. Right? Okay, what are the application? The high starting torque and controllable speed applications. Controllable speed applications. Can you tell me the example? What are the examples? For slip ring induction motor applications, what are the examples? First one, generally hosting machines. Hosting machines. What are the applications? Let's see here. Applications of slip ring induction machine. Applications of slip ring induction machine. Applications where we are using generally high starting torque and controllable speed applications. Controllable speed applications. Controllable speed, nothing but resistance control speed. By controlling the rotor resistance, we can control the speed. What are the example? What are the applications example? Like a hoisting machines. Hoisting machines we are using. Like a lifts we are using. And like a traction. Traction motors. Generally we are used. Traction motors. And generally we are using in cranes. Cranes. These are the best examples for applications of slip ring induction machine. What are the applications of slip ring induction machine? First one, hoisting machines. Second one, lifts. And next one, traction. And next one, cranes. And next one, elevators, etc. These are the best applications of three-phase slip ring induction machine. The best applications of three-phase slip ring induction machine. This is simply about the slip ring induction machine. Okay. Next one. Second one, squirrel cage induction rotor. Squirrel cage induction rotor or squirrel cage induction machine. Right? Let's see the features and different points about squirrel cage induction machine. Let's see here. Generally, the squirrel cage induction machine is look like this. This is my squirrel cage induction machine. Now the first question, which type of winding we are using here in squirrel cage induction machine? Which type of winding we are using? Option A, concentrated winding. Option B, distributed winding. Option C, uniformly distributed winding. Option D, none of the above. Which type of winding we are using in squirrel cage induction machine? My options are option A, concentrated winding. Option B, distributed winding. Option C, uniformly distributed winding. And option D, none of the above. Which of the following is preferable? The answer is none of the above. There is no winding, sir. In squirrel cage induction rotor, we are not use winding. There is no winding we are using. No winding we are using. But we are using a high cross-sectional area. High cross-sectional area. High cross-sectional area copper bars. We are using high cross-sectional area copper bars here. Generally here we are using high cross-sectional area copper bars like this. High cross-section area copper bars. In squirrel cage induction machine, we are using high cross-sectional area copper bars only. There is no winding we are using. No winding we are using. And next question. Generally, in squirrel cage induction rotor, the rotor is short-circuited here. Up to now in slip ring induction machine, rotor not short-circuited. Rotor terminal is connected to the slip rings. But here, the rotor is short-circuited. Now tell me, here rotor is short-circuited by using. Can you tell me, what are these? These are called as, these two are called as. These two are called as end rings. These two are called as end rings. In squirrel cage induction machine, the rotor is short-circuited by end rings. The rotor is short-circuited by end rings. Can you tell me the end rings made up of? End rings made up of? End rings made up of forged copper. End rings made up of forged copper or copper alloy. End rings made up of forged copper or copper alloy. What is the meaning of forging? What is the meaning of forging? Forging nothing but the process of continuous hammering. Forging nothing but the process of continuous hammering. Sir, why we are hammering? Why we need for this process? Why we need this process? Because by this continuous hammering process, we can increase the mechanical strength. First one, we can increase the mechanical strength. And next one, conductivity. Next one, conductivity also increases. Conductivity also increases. The rotor is short-circuited by using end rings. Every rotor having the two end rings. Every rotor having two end rings. The end rings are made up of forged copper. Forging nothing but the process of continuous hammering. The process of continuous hammering. Why we are hammering? The process of continuous hammering gives you high mechanical strength. High mechanical strength and high conductivity. High mechanical strength and high conductivity. That's why we are using this forging copper. High mechanical strength and high conductivity. High conductivity. Okay, in this rotor we don't using any winding, just we are using high cross-section area copper bars, and that rotor is short-circuited by end rings made up of forging copper. You know what is forging and why we are going to forging, you know. Now here, very important point. Now here we are using high cross-section area copper bars. High cross-section area, generally R is equals to rho L by A. R is equals to rho L by A. If cross-sectional area is more, then resistance is less. If resistance is less or cross-section area is more, the current carrying capability is very high. Yes or no? If resistance is less, it carries more current. Generally, the current carrying capability also decided by area, cross-section area of conductor. If cross-section area of conductor is more, it carries more current. So the current carrying capability is high. Nothing but indirectly the overload capacity is very high. the overload capacity is very high for squirrel cage rotor. This is very, 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 very important. The overload capacity is very high for squirrel cage rotor. Overload capacity is very high. In slip ring induction machine, starting torque is very high. In squirrel cage rotor, the overload capacity is very high. Now, can you tell me what are the applications of squirrel cage induction machine? What are the applications? Generally, this is used for high overload capacity applications. Right? Next one. Here also, the poles of the rotor motion should be equals to poles of the stator. This is 100%. The poles of the rotor motion should be equals to the poles of the stator. And here also, the phases of the rotor may or may not be equals to phases of the stator. The phases of the rotor may or may not be equals to phases of the stator. Based on this, they are asking one question, one problem. Generally in IES and GATE, they are asking one problem. See here, my problem is that. My question is that a three-phase squirrel cage induction motor. In rotor, I having 36 slots. In stator, I having 48 slots. They are asking question. A three-phase 50 heads. A three-phase 50 heads, 6-pole. A three-phase 50 head 6-pole squirrel cage induction machine. Rotor having 36 slots and stator having 48 slots. Now can you tell me how many number of rotor phases are there and how many number of stator phases are there? Now they are asking question, the number of rotor phases and number of stator phases. They are asking question. A three-phase 50 head 6-pole squirrel cage induction machine, rotor having 36 slots and stator having 48 slots. Now tell me the rotor number of phases and stator number of phases. How we can? We have a small formula for this. The rotor phases is equals to rotor copper bars by poles, number of poles. Rotor copper bars by number of poles. This is the formula. The rotor phases is equals to rotor copper bars by number of poles. Now can you tell me what is answer for rotor phases? The rotor phases is equals to how many number of rotor copper bars are there? Generally here we have a 36 slots. If they are not mentioned anything, we have to consider it as a singleton coils. Every slot contain one copper bar. For 36 slots, how many copper bars are there? 36 copper bars are there. How many poles are there in machine? 6 poles. Now tell me, how many phases are there? 6-phase machine. The rotor having 6 phases. Okay, very good. Can you tell me how many number of stator phases are there? Sir, we know, sir, very easy. Number of stator phases is equals to, what is 48 is there? 48 by 6 is equal to 8 phase. This is 100% wrong answer. Sir, you said that. Yes, I said you the formula for rotor phases. But I didn't give you the formula for stator phases. And I already given in my question, my machine is the 3-phase machine. I told you my machine is the 3-phase machine, but you are telling me the answer, one is the 6-phase, another one is the 8-phase. Then why it is called as 3-phase machine? Yes or no? So, can you tell me how many number of phases are there in stator? In stator, we are having only 3 phases, sir. Because this is a 3-phase induction machine. Generally, we are giving the 3-phase supply to the stator. Generally, we are giving the 3-phase supply to the stator, sir. That's why the stator having 3 phases. But the rotor phases may or may not be equals to stator phases. Rotor phases may or may not be equals to stator phases. That's why we have a formula for rotor phases. The rotor copper bars by number of poles. That's why 36 by 6 is the 6th phase. For rotor, we have a 6 phases. But for stator, we have only 3 phases because my machine is a 3-phase induction machine. Don't do like this. This is 100% wrong answer. Don't do like this. Right, sir? This is asking there some questions. Right? Now, let's see here. So, generally, this is about the squirrel cage induction machine. In squirrel cage induction machine, the rotor is short-circuited by end rings. And here we don't using any winding. Just we are using high cross-section area copper bars. That's why resistance is less and current carrying capacity is high. Nothing but overload capacity is high. And the number of poles should be same, but number of phases may or may not be same. And we have a formula for rotor phases. Now the question is that, now how to increase my starting torque? I want to increase my starting torque and also I want to increase my power factor. How we can increase? Sir, we know that generally the starting torque is directly proportional to rotor resistance. We know. And power factor cos pi is directly proportional to R by Z. We know. And starting current is equals to V by Z. We know, sir. By increasing the rotor resistance, we can increase the starting torque and we can increase the power factor. We already saw in slip ring induction machine. But here there is no possibility. To add extra resistance. Can you tell me why there is no possibility? There is no possibility, sir, because the rotor is already short-circuited. How we can add extra resistance? The rotor already short-circuited. There is no possibility to add extra resistance. That's why we cannot increase starting torque, we cannot increase starting power factor, and we cannot control the starting current. This is the disadvantage. Nothing but here we cannot add extra resistance. That's why we cannot add extra resistance. Hence, we cannot control the starting current. And there is no capability to increase the starting torque and power factor. But this is possible in slip ring induction machine. This is not possible here. And next one, in slip ring induction machine, the resistance control method, the speed control by rotor resistance variable method we are using. We are preferable that one. But here, that is not at all preferable. There is no possibility to add extra resistance. Then how we can control the speed? So that is not possible here. But I said you in slip ring induction machine, the speed control by pole changing method is not preferable. In slip ring induction machine, speed control by pole changing method not preferable. But here, that is well preferable. The speed control by pole changing method is well preferable. Sir, how? Generally, I told you already, here we don't using any winding. But in stator, we are using distributed winding. It's already in stator. In stator, we are using short pitch distributed winding. Nothing but in stator, the poles are formed due to winding. In stator, poles are formed due to winding. But in rotor, there is no winding. Then how poles will be created, sir? How poles will be created? Yes, the poles are imaginary actually. The poles are magnetic image. That is simply called as the magnetic replica. due to this magnetic replica, automatically the poles are induced in the rotor, which is exactly equals to the stator poles. Nothing but actually there is no poles in the rotor actually, but we have a magnetic image, just a image, that's it. That is called as magnetic replica. Due to magnetic replica, the poles are formed in the rotor circuit, which are exactly equals to the stator poles. Hence, poles are equal. And if you control the speed by pole changing method, just now we are going to change only poles on the stator. Nothing but the winding of the stator. Just by changing the winding of the stator, automatically the poles changed in the rotor, because how the poles are there in the stator, those poles are magnetically image will be developed in the rotor, that's it. If you have a 2 poles in the stator, the same magnetic replica will be represented in the rotor. If you have a 4 poles in the stator, the same magnetic image will be present in the rotor. If you have a 20 poles in the stator, the same poles will be induced in the rotor due to magnetic replica. That's why if I want to change my speed by pole changing method, just by changing the stator poles, we can change. No need to change the rotor winding or rotor copper bars, etc. That's why the pole changing method is well preferable here. Right? This is about the slip ring induction machine. Now the question, very important question. Now the question is that what are the applications of slip ring induction machine and squirrel cage induction machine? We already saw the applications of slip ring induction machine: high starting torque, controllable speed applications. Now tell me, what are the applications of squirrel cage induction machine? The applications of squirrel cage induction machine: overload capacity applications, and uncontrollable speed applications. Generally, the pole changing method is somewhat difficult. If you have a extra resistance added to this, that is very easy method actually, but there is no possibility. That's why high overload capacity applications which are not controllable, in those applications generally we are using. Can you tell me what are the examples? Tell me. Generally we are using in pumps. Which type of pumps? Reciprocating pumps and centrifugal pumps. Generally in bore wells we are using motors, right? Generally in irrigation system we are using motors, right? 5 HP motors, 10 HP motors, both generally all the motors are squirrel cage. So in reciprocating pumps and in centrifugal pumps, and also generally used in compressors, and generally these also used in rolling mills. Generally used in rolling mills, like these applications. What are the applications? High overload capacity and not controllable. What are the examples? Reciprocating pumps and centrifugal pumps and compressors and rolling mills. High overload capacity. We required here high overload capacity. These are the applications of the squirrel cage induction machine. Okay, this is about the squirrel cage induction machine.